Thanks for having me here and welcome everyone. My name is Sahina. I work as a senior engineering manager at Red Hat. At Red Hat, I work on software-defined storage solution and its integration with virtualization and container platforms. So today I wanted to talk to you about how you can bring hyperconvergence to your data center using all open source solutions. So these are the key takeaways that I want to leave you with. One, what is hyperconvergence and why all the buzz around it? And what are the open source solutions that we have? And we will look into one of these solutions, the overt hyperconverged, and see how you can use it, how it works, etc. First, let's look at the problem. There is an increasing demand for software solutions. Customers are demanding for newer and better solutions. And most organizations struggle with limited budget and space to house all these servers and infrastructure that the growing demand needs. There is, even if you do have that infrastructure, there is also the skill staff that is needed because you have now multiple kinds of infrastructure that you need to manage and administer. So there is always a lack of skilled staff to do that. And the needs of infrastructure are increasing at such a rapid rate that how much ever servers you throw at it, it's never enough. So this is where virtualization came in. Virtualization is when you take hardware and then bring a software abstraction layer to create a virtual version of something, be it servers, be it storage. So now there's all kinds of virtualization. There is the server virtualization, the storage virtualization, network virtualization, you name it, everything is being virtualized now. So in fact, I think 92% of the world's businesses use some form of server virtualization or other, be it the public cloud instances where you run your virtual machine instances and use the public cloud infrastructure, or even on-prem when you bring, virtualize your environment. So even though there is virtualization, the siloed nature of this is inefficient. So we have storage where it's managed by a separate team that also procures it and kind of administrates it. And then you have a different team looking at your servers for your compute needs and another team looking at networking. Or maybe there is just a single team looking at all of these. But even so, the inefficient usage of this hardware that you have leads to problems. So there can be a better way of managing this, right? So that's what we come to in the next step, where we bring network, compute, and storage into a single box or an appliance. This is what's known as hyperconverged infrastructure, or HCI, as it is most commonly known in the market. So with hyperconverged infrastructure, you have a single solution that you need to evaluate, that you need to manage, a single infrastructure that you need to upgrade, to scale, and to secure. And even when you do have problems, there are, I think, a lesser number of people that you need to contact to be able to solve these issues, to administer this infrastructure. So the use cases for HCI is vast. There are multiple use cases out there. I have just put some of it. The first and foremost is, of course, the consolidation of your servers. So you use one single server to run multiple virtual machine instances. And these virtual machine instances could be running your database or your production workloads. They could, you could run pretty much everything that you run on the servers on your virtual machine instances. There is the robo use case, also known as remote office, branch office. In this use case, you have a limited infrastructure at your branch site. So maybe you have 2 or 3 servers that are running on the branch site to manage the branch operations. And periodically, you then contact your corporate office or your headquarters and sync that data, or make sure you consolidate everything across branches. So this is also evolved into the edge infrastructure, where you're running things on the edge using a smaller footprint of servers. The dev test environment is another use case, very popular with developers. So in this, you have developers who want to have a very similar environment that they have in production when they're testing a change. So suppose they have created a new feature or have fixed a bug, they want to test it out in a replica of your production environment. So they spin up test virtual machines where they try this out, and once they are satisfied with the result, then promote it to the production instances. So this HCI infrastructure is very well suited to do something like this. There is the VDI, or desktop as a service, which has been around for quite some time. So many more such use cases. I think people are innovating, doing various kinds of operations with the infrastructure that they have. And if we do look at the HCI market today, so it's at 2020, it's at $7.8 billion, and it is poised to grow at a very rapid rate to $27 billion by 2025. And if you look at the green bars here, that is the APAC market, and you see such a rapid rise in the APAC market, which means that every one of you here in this talk today either have a hyperconverged infrastructure in your organization or will be getting one soon. So, but if you do look at the market share, 75% of this market is dominated by 3 or 4 players. And why wouldn't you go with one of these players to bring a hyperconverged infrastructure to your premise? So one, of course, is the high cost. I think it's very expensive. The CapEx expenditure that you need to spend on it is going to be huge. And most small and medium businesses cannot afford to go with one of these vendors and create a hyperconverged infrastructure in their environment. There is also the other issues that you may or may not be concerned with, being proprietary solutions, lock into a single vendor, etc. And a question of the hardware as well, right? So if you already have some existing servers, can you run a solution offered by these vendors on that existing hardware? May or may not be possible, but in most cases, I'm sure the appliance will be provided by the vendor. So what are your options if you are a small or medium, or even if you are an enterprise and you want to reduce the cost? What are your options? There is a lot of open source solutions out there. I think if you just do a Google search, you would find quite a lot of virtualization and storage solutions out in the market. On the screen, I have listed just some of them. And most of these are the ones that Red Hat is majorly associated with. So if you look at some of the solutions out there, there is OpenStack and Ceph, which can provide you a private cloud-like infrastructure. So you can use the OpenStack to deploy infrastructure that simulates a public cloud kind of infrastructure, along with Ceph, which provides a storage solution. There is OpenShift that meets any of your container needs. So OpenShift is a distribution based on Kubernetes, and it builds on top of Kubernetes to provide many enterprise features that can be used for your container orchestration needs. There is also the building blocks, so to speak. So you have KEMU, you have KVM, and then you have the automation engine Ansible. Using all of this, you can build your own custom solution as well. But today, I will be focusing on the hyperconverged solution that is built using Overt and Gluster. So the Overt hyperconverged infrastructure, or Overt HCI, as I'm calling it, is a solution built with Overt and Gluster. So Overt, like any mature open source project, is not just a standalone project, but an integration with multiple open source projects. As you see on this slide, there is quite a large number of projects that Overt is integrating with. And I did mention before that you could build your own. So you could have, your own virtualized management system using libvirt, KVM, KMU, or you could just use Overt, which has already done all this integration for you. And today I will focus on the two main components that are used to bring a hyperconverged infrastructure, which is Overt and Gluster. So first, Overt. So if you look at what is Overt, it is a large-scale centralized management of server virtualization. So Overt provides all the advanced virtual machine capabilities that you expect of any enterprise system. So you have the high availability of virtual machine instances. You can make sure your virtual machine is running even when one of the server goes down. So, well, that is high availability. And then you have possibility of live migration of virtual machine instances, including live storage migration. You can choose when, where, and how you want to schedule these virtual machine instances. There are multiple scheduling policies that Overt supports. There's also disaster recovery capabilities. So if you want to make sure that your data is replicated to a different site and you can recover from a disruption at your primary site, you can do that via the disaster recovery options that are available with Overt. So Overt is a mature product. It has a very large user base. It has been around since 2009. And we have been releasing at a very regular cadence. So it's not something that is not actively maintained. It is actively maintained. Overt is used in production by multiple companies, from hosting companies to universities that use Overt in their environment, to hospitals. So you can look at the Overt web page given here and see the various use cases that Overt supports. So if we now look at the architecture of Overt, there are three main components. So there is the engine at the top. Engine, as we call it, is a Java-based application that provides a web administration portal as well as a user portal. And engine is the main component that orchestrates and manages the hypervisors underneath it. So you have hosts that run your virtual machine instances, and then you have the storage that the virtual machine instances actually use. So the disks are stored on some storage. The storage can be any NFS share or even SAN, or even any POSIX compliant file storage will also work. Overt works on KVM hypervisors. So these are the hypervisors that it manages. And the application engine runs on Wildfly and uses the PostgreSQL database. So I have not listed all the components, but at a high level, this is what Overt looks like. Moving on to the other component, which is Gluster. So Gluster is a distributed open source storage solution. It can scale up to petabytes of storage across hundreds of nodes. And Gluster works on any commodity hardware. So all it needs is some kind of storage, be it direct attached storage, or just a bunch of disks, or even SAN. It can work with any storage. It aggregates these storage exports across the network and provides a unified namespace. And Gluster supports multiple protocols. You can use NFS to access it. You can use SMB or CIFS if you're accessing it from Windows machines. It also provides a native views protocol via the native GlusterFS client. Gluster does have APIs that you can use to integrate from your application to connect to the storage. And I think in yesterday's multiple talks, people were focusing on the lack of open source products from India. And I am really proud to say that Gluster was actually engineered in India. It was founded in 2005 with the engineering team based out of Bangalore, and later acquired by Red Hat in 2011. So yeah, and Gluster continues to be open source. used by multiple companies across the world. I know Facebook, Microsoft, all of these companies do use Gluster in their organizations in some form or the other. So you have the products, you have the architecture. Now, how do you go about using this? I mean, all of that integration, everything seemed so complex, right? But how do you go and download this solution, and how do you install it in your organization if you don't have those skills? So it's fairly simple. I have provided a screenshot from the overt download page. And if you look at it, all you need is to download the enterprise Linux, any CentOS or RHEL host would do. If not, you could also use the overt node. Overt node is an ISO. It's a combination of all the packages that it requires, a minimal combination of the packages that it needs to run the hypervisor. So you can download overt node from the website, the download page as well. So once you download, now what? How do you get from these three commodity servers that are, networked together with a switch, and how do you get from there to a hyperconverged architecture that you see on the right? So if you look at the hyperconverged architecture, you have the disks on the servers. In this example, I have provided 3 servers. So you have the disks on these 3 servers, and now you want to build together this architecture where you have GlusterFS running on the 3 servers, the LVM provisioned on the storage, and Gluster provisioned into a Gluster volume, a large storage that is shared across the 3 servers. And the servers now run all the virtualization components, KEMU, KVM, libvirt, and VDSM, which is a daemon that overt requires to manage and monitor these. And once you have all of this set up, now you can go and create virtual machine instances. So this does look a little intimidating, but I want to show you a small demo and to show you how easy it is to set this up. So it is easy for you to get from these, commodity servers that you have in your environment and to set up a hyperconverged system where you can run this in production and manage and monitor your virtual machines. So let's go to the demo. So this is a page where I have downloaded the overt node onto one of the servers. So you have 2 options. You have option to either install just the engine, the hosted engine as we call it, and run this connecting to some storage system that you already have. Or you could run it as a hyperconverged installation, which is what we will focus on. And the hyperconverged installation uses the server that's available uses the storage that's available on the servers. So if you look at the hyperconverged deployment, you can run this on a single node, which is not really suitable for production, but it's available to you, of course, if you just want to try it out. Or you can run this on a minimal of 3 nodes. So you have the 3 servers, so you provide the host name that you are going to, the host names of the servers that you're going to use. We do recommend splitting the networks so that the storage is on a different network and the VM communication are on the public network. Once you provide the details for the servers, then next step is to provide the volumes. So the volumes are the Gluster volumes that we used. So Gluster volume is the unified namespace that I talked about. So we have storage for specific use cases. Here, the engine, which is your hosted engine, needs some storage. So that storage is provided by a separate volume. And then you have your other volumes that host your virtual machine disks and instances. So if we look at this, we do have the storage servers and then the server storage that's available, the disk that's available on each of the servers. So you can choose to have a uniform deployment. where each of your servers are very similar. And so then you can just use the same set of disks that are available on all these servers, or you can have a non-uniform deployment, but then you can provide the disk names from each of the servers. So it supports various options. It supports dedupe and compression, where you can use this for some space savings. It compresses the data that's written onto the disk. This is particularly useful for a VDI kind of use case, where everything is very copies, replicas of each other. Data doesn't differ much in such cases. So you can choose to do that. You can choose to configure a cache to speed up your system if you have flash storage associated on the disk. There are also multiple combinations of volumes that you can use for space saving. So once you configure this, what it does is it generates an Ansible playbook, and it executes the playbook from the GUI. So if you can see, it does allow you to go and edit that playbook if you were to customize it, or it just runs that playbook and sets the whole thing up for you. So this is where it runs the playbook. You can monitor the progress on the screen or even on the logs. So once this environment is set up, this is only the storage setup part of it. So once this is set up, you can go to your terminal, and you can see that, well, it is going to the terminal. You can see the Gluster volumes that are created. So Gluster volume has used storage from the 3 servers that we have provided. And all the options, everything that is needed for you to run a virtual machine use case is already tuned. And if you dig deeper into your storage disk, all of the LVM provisioning, the thin pool creation, all of this has been already done for you. So there's really no manual steps involved here. So that was the storage provisioning part of it. So the next step, once you have deployed storage, is to go to the installation of the hosted engine. So the beauty of this is that normally you would require to run your manager on a separate server and then manage the 3 servers that you have just configured, right? But with this, the manager or the hosted engine is actually just a virtual machine. So this is first bootstrapped. So there are some settings that it asks you for. What is the FQDN that the engine manager is running on? What are the interfaces that it should use? What is the password to access it, etc. So once you provide all of these details, it's going to spin up virtual machine instances. So it's kind of bootstrapping itself to manage the infrastructure that it's running on. So once you provide all of these steps, again, it goes and gives you another set of details on what you have provided. And it again runs an Ansible playbook to set this up. So the prepare VM does take time. It prepares the local disk. It does all of this on the local storage. So once you have created your virtual machine instance, now you need to move that virtual disk to the shared storage that we have already provisioned. So the shared storage was the Gluster volume that we have used. So it's going to now move that local disk onto the Gluster volume. And since all of this is in a single flow, everything is pre-filled for you. There is not really much you need to edit except for the server instances, the disk that you have given, and the virtual machine configuration details like FQDN and network details. And once you do this, the finished deployment step is what copies that local disk onto the storage server, and now your environment is set up. So with that wizard-like interface, you have now been able to provision the 3 servers and set up the Hyperconverge infrastructure. Quite simple, isn't it? Now we see once you have the now, once we have this setup, this is where you can see the dashboard. So this is the administration portal that I talked to you about. The engine provides the administration portal where you can look at what are the storage domains available, how many virtual machine instances are running, and get insights into the usage. How is your CPU utilized? What is the storage utilization? Alerts are also available here. You can integrate with any other alerting platform so that you're notified of issues. There is also a user portal, and there is authentication and role-based access provided by integrating with any AD system, any IPA or anything that provides the authentication systems. So that was on how this whole thing is set up and how you can use the Hyperconverge infrastructure. So that brings me to, you can contribute. Contributions are most welcome. So first, go and use this system. There are multiple ways of contributing. You don't necessarily have to contribute to code every time you go and contribute to an open source project. There are many other forms of contributions that are welcome. One, you can actually use the systems and then join community discussions about it. You can provide insights to other users on how you used it and how that has helped you. File bugs. If you have seen some problem, go ahead and file bugs. All the links are available on the websites that I have linked there. Join surveys, say what you want. If you feel like your feature is missing and you want some feature, make your voice known. The only way that a project develops and project matures is when the users start engaging with the community and share case studies, promote these on social media. I don't see very many use cases from India. So maybe we can set this up on our universities, maybe set this up in your organization and promote it on the social media. And that brings me to the end of the talk. Thank you for listening.
Thank you, Sahina. That was a wonderful, wonderful session. I thank you on behalf of Open Source India, as well as India Technology Week platform. Now we have a question, which is what if my disk or our disk are in hardware RAID mode? What to do then?
So if you have already disks on hardware RAID mode, it doesn't matter because you are making sure you have a double protection. So at the storage software layer, we do make sure that data is replicated and we have some redundancy. And at the RAID layer also, you have your own redundancy, right? So this is actually a double protection. Gluster works with any RAID level. So it works with RAID 0, RAID 6. There are, of course, certain optimizations that it requires for performance reasons. But RAID is definitely not a problem. It can work with any RAID.
Perfect. The second question is, can we try what you mentioned in a standalone machine for a demo?
Yes, of course. When I talked through the wizard, I did show two options, right? One is run on a single node and then run it like a production environment. So the run on single node is you can use it on your server and you can try this out right now, today. So, just to try this out, you can, of course, try it on a single server. The only thing that you're missing out is the high availability, because if that server goes down, all the instances on that is lost. So to make sure that you don't want that to happen is when you run it on multiple servers.
Perfect. One last question. Why is it necessary, or is it necessary at all, to hyperconverge data centers with open source?
Why is it necessary? Well, I think it's all about choice, right? Like I told you, with the open source solutions, you have a number of choices, and you can run it on the server and commodity server that's available to you. And open source also means that it's scalable. You are growing with the community. You influence how the project evolves as well. So that flexibility and freedom, I think, are the important choices that it's up to you, basically. But I would say that those were the important choices that you would make.
Perfect. Thank you so much, Sahina. That was a wonderful session, and I'm sure the crowd and the audience loved it. Once again, I thank you on behalf of Open Source India 2020. I thank you on behalf of India Technology Week platform as well as Electronics View.